Good morning, everyone. I would like to welcome everyone to the 30th ANAN webinar on radioactive waste management on site selection for disposal facility. To moderate the webinar, I would like to invite Yasir, Dr. Yasir Kazisas, ANAN steering committee member, and also to speak a little bit about ANAN. Yasir, please, you have the floor.
Thank you, Marina. Good morning, everyone. I would like to share some information about ANN webinar series, and then I will invite my colleagues to present some presentation about waste management system. It is ANN webinar series in the field for different field of nuclear science and technology, from radiopharmaceutical to nuclear power plant, radiation medicine, etc. And all webinars will be recorded and is accessible through ANENT website. I invite all of you to go to the ANENT LMS system website and see the previous webinars and access to some all e-learning and outreach activity that we have in this repository. And let me introduce my colleagues for today webinars. Today webinar, we have two outstanding presentations, speakers today. The first one is Mr. Dr. Reza Rezvani Nejad. He is graduated from Iran University of Science and Technology, and he has master's degree in chemical engineering and have a good experience, perfect experience, more than 25 years in Iran Radioactive Waste Management Company. And he is also currently is the technical and engineering management of this company. And another speakers that we have today is Mr. Burumandi, Dr. Burumandi is also graduated in engineering geology and have more than 15 years in Iran Radioactive Waste Management Company. Today, we will know more about radioactive waste management and how we can manage this radioactive waste and how we treat this waste and disposal radioactive waste in the specific site. Okay, I would like to invite first presentation, Dr. Rezvani Nejad, please.
Yes, thank you. Let me share. Okay, thank you, Dr. Costas. Can you see the first page of my presentation? Yeah, yeah.
Yes, perfect. Yes, yes.
Yeah.
Yes.
Shall I start?
Yes, please.
Okay. Good morning, everyone. As Dr. Costas introduced myself, I don't need to introduce again. I'm proud to give a general presentation related to radioactive waste management for dear audiences. If possible, I can present each of the audience's chosen topics in more detail and in depth via and in the near future. Due to the wide scope of the subject and its many components, it's been tried to convey it to the audience more easily by using only a visual understanding and focusing on the general issues. It should be noted that the slides are presented in order, in a sequential order, based on the implementation of different stages of radioactive waste management. And in fact, there is a sequential logic from the beginning of encountering radioactive waste to the end, which is mainly the disposal process. It's necessary to mention that the documents available in the IAEA publications will undoubtedly the most complete reference for all interested bodies, parties, or audiences. I should add the scope of this presentation is out of the spent nuclear fuel management. For quick and better understanding of the material, the following 5 topics have been observed in this presentation. First, number 1 is a general information about the topic. The second is explanations about explanations with the images based on the figures. Number 3 is activities and steps of radioactive waste management is in order or in a sequential order. 4, in each slide, I try to mention the reference to IAEA publications and standards. Number 5 is a structure-based, this presentation is structured based on the radioactive waste steps and activities. Okay, let's take a look at the contents as outlined. In the introduction section, I'd like to mention main definitions about the radioactive waste management. Then I go through the radioactive waste classification, then radioactive waste management activities, radioactive waste characterization, waste acceptance criteria, or its abbreviation is WAC, is something that I will present in the introduction. Okay, before I go through the next slide, imagine that the waste packages, like humans, must be buried at the end of their management processes. Therefore, their management is divided into 2 parts, 2 sections, disposal and predisposal, each of which has steps that I will explain more. So the predisposal management is the second part of my presentation, and the last one is radioactive waste disposal process. Okay, you can see the IAEA safety standards in pyramid. It's completely familiar for experts. As I explained before, there are several standards and technical documents published in IAEA. Maybe you may know the nuclear industry may have many similarities with other industries and even advantages, but the important issue is the special attention that must be paid to the nuclear safety issues. This safety is related to the safety of people and environment. Therefore, the agency's standards are specifically published as safety standards. You can see in this pyramid, safety fundamentals are at the top of the pyramid. Safety requirements, safety guides, safety reports, technical documents. Okay, let's go to the publication. There is one general publication involving 10 principles in safety fundamentals, safety standards. About our topic I'm presenting today, radioactive waste management, there are 12 publications in safety requirements. And in the topic of radioactive waste disposal facilities, there is just one publications in IAEA standards. And for the third categories, radioactive waste management, there are 15 publications we have in safety standards. And the last one is radioactive waste disposal facilities. In this area, we have 6 publications. Okay. Uh, in the introduction, I'd like to present some definitions, some main and basic definitions about radioactive waste management. Um, Radioactive waste, in effect, this is based on something developed in the IAEA glossary. Um, this is the document. I try to show every individual publications of the IAEA in every slide. Okay, radioactive waste, in effect, radioactive material in gaseous, liquid, or solid form for which no further use is foreseen. Right now, actually, no further use is foreseen. And then we can see radioactive waste management. The definition is all administrative and operational activities involved in the handling, pretreatment, treatment, conditioning, transport, storage, and disposal of radioactive waste. I will explain more about every word of this paragraph. Okay. I intend to try to mention these activities in order. Okay. Okay. In the definitions, you can see the major radioactive waste generators here. This presentation actually doesn't attempt to explain how radioactive waste is generated, but rather assumes that the waste was generated in facilities that we are now faced with managing it, or what to do with it. Okay, there are some major radioactive waste generators, nuclear power plants, the most radioactive waste. The other nuclear fuel cycle facilities like enrichment facilities, uranium conversion, mines, NORM, and etc. Radioisotope production plants, medicine, agriculture, universities, research, and the other industries. Okay, the sixth slide, because the ultimate goal, final goal is to place waste packages. I will explain waste packages to their audiences. Because the ultimate goal is to place waste packages in the various repositories, knowing that what classification, what level, what activity content, what half-life of every individual radionuclides, what classification the waste is must be determined at the very beginning of the stages. Okay, maybe you are familiar with this figure. The y-axis is activity content and the x-axis is half-life. This is the basic of classification of the waste. You can see at the bottom of this figure exempt waste and very short-lived waste, very low-level waste, intermediate level waste, and at the top of the figure, you can see the high-level waste that needs to be disposed in the deep geological disposal facility. Okay. The definition of the waste classification system is the waste classification system is disposal oriented, as I explained a little bit sooner, and can be used to help establish appropriate disposal concepts, develop preliminary waste acceptance criteria. I will explain about this term and other requirements. And this is the general safety guide of the IAEA, GSG1. Okay. I think it's useful to have some statistics on how much different countries around the world have stored and how much they have disposed the waste packages in their own countries. You can see in the table that based on the IAEA estimates on 2022, I'm pointing the third column. Yeah, I'm pointing the third column, proportion of waste type in disposal. You can see that almost 80% of very low level waste has been disposed, and for its shares for low level waste, it's 92%. And for intermediate level waste is just 5%, and for high level waste there is no disposal system up to now. Okay, I'd like to I'd like to I'd like to I'd like you to pay much more attention to this figure. Now, this is in fact the roadmap for radioactive waste management activities, which all interested audiences and parties and bodies can better understand by having a visual understanding of it. Radioactive waste management can be divided to the predisposal management and disposal. And disposal management can be categorized to the three main elements: processing, storage, and transport. And the main one is processing, that which I will explain about that in much more detail in this presentation. Okay. For your better understanding, radioactive waste management can be divided to the predisposal management and disposal management. You can see the margin of my slides, and the outline of this slide is based on these two terms. Okay. Characterization of waste, determination of the physical, mechanical, chemical, radiological, and biological properties of radioactive waste to establish the need for further adjustment, treatment, or conditioning, or its suitability for further handling, process, storage, or disposal. Uh, Imagine that at the very beginning stages of radioactive waste management, you shall know that what the waste is, what is the characterization of waste, what's the specification of the waste, the content, the dose, and the something that we have in our hands. And characterization of waste is a process in predisposal management of waste. When we go through the other steps in storage or disposal, it's not the time to understand what was the waste, what do we have in our hands, and WAG. We have encountered the term WAG several times so far in this presentation. It's best to summarize that this essential and important document contains the criteria that waste shall meet in order for waste to be consigned, to be transported between the generator site and the waste management operator. Criteria, for example, something that the table of content of this document has, for example, criteria, for instance, radiological, physical, or chemical properties the waste package shall have, that the generator should required to meet and give the waste packages to the operator of the disposal facility for acceptation. And there is a chapter in this document, non-compliance management records, and something else. I don't want to go deeper in this document. And in summary, WAC is a document involving quantitative and qualitative criteria specified by regulatory body or an operator, and will be approved by the regulatory body, and will be distributed between the generators. and they shall be obeyed. For the it is developed for the waste form and waste packages and will be accepted by the operator of a waste management facility. Okay. Uh, Characterization of waste. So characterization of waste is a collection of properties, radiological properties, physical and chemical properties, and biological properties. So the generators are required to specify their own radioactive waste or characterization process. And you can see these two photos are related to the systems or equipment which help to characterize the content or dose of the packages. Like, for example, drum scanners, dosimeters, or in some cases by have by have destructive tests, same as get some cores from the radioactive waste packages or radioactive waste forms. And let's come back to to our roadmap. Okay, this is the predisposal management, and the main part of it is processing sector. It's essential. It's important to note that the major technologies are used in the processing sector. For what? For bring the waste package to a suitable, to a stable state that can be, then after that can be stored, transported, or disposed. It is categorized to three main elements: pre-treatment, treatment, and conditioning. And this is the specific safety guide of IAEA publications, predisposal management of radioactive waste from the use of radioactive material in medicine, industry, agriculture, research, and education. It is so important. Safety standards, SSG 41, 45, sorry. Okay. In the processing part, we have three terms: pre-treatment, any or all of the operations before to waste treatment, such as collection, segregation, chemical adjustment, and decontamination. What the segregation mean? What is the meaning of the segregation? It means an activity where types of waste or material, radioactive or exempt waste, are separated or are kept separate on the basis of radiological, chemical, and or physical properties to facilitate waste handling and or processing. And the last one is decontamination. Decontamination means the complete or partial removal of contamination by a deliberate physical, chemical, or biological process. These are based on the definitions presented in the glossary. These three stages are the most basic activities that are carried out on waste received from various sectors. Okay, we can see here processing in this treatment. Without any exaggeration, it can be said that this process is one of the most important activities for the disposal facility operator. For what? For bringing the waste to optimal condition, to the conditions that he needs, the operator needs to store, to dispose. Okay, let's go to the definition. Treatment means operations intended to benefit safety and our economy by changing the characteristics of the waste. Treatment methods. There are three main methods, three main operations for treatment. Volume reduction, for example, incineration of combustible waste or compaction or super compaction of dry solid waste, then radionuclide removal, evaporation process, filtration or ion exchange of liquid-based streams. And the third one and the last one, change of composition. For instance, is precipitation or fluctuation of chemical species. Okay, you can see the incineration, one of the incineration plants. Actually, one of the most common methods of reducing the volume and mass, mass as well as volume of mainly solid waste is incineration. Incineration, which is one of the best options, one of the best options if sufficient and complete attention is paid to the processes of filtering and trapping the pollutants in the output streams when they are going to the environment. This is the main problem and challenging issues for the incineration. Okay, incineration of dry solid or organic liquid. Organic liquid and small percentage of wet waste, radioactive waste. It's mainly for combustible materials. It significantly reduces the volume of the waste. Volume reduction factor is about 30 times, and also reduces its mass by 80 to 85%. And it is actually undoubtedly well proven technology. And this is another method, pyrolysis. Pyrolysis is one of the methods that treats the radioactive waste is an almost air-free batches in the beginning stages. Pyrolysis extensive commercial experience, for example, in China, in the processing of high organic content waste. And this is the low process temperature. This is the low process temperatures retention of volatile species in the ashes, retention of radioactivity in pyrolyzers residue is almost 100%. And one of the other advantages it has is low gas flow rates, in the effluent streams compared to incineration. And the third one is generally for the non-combustible radioactive wastes is compaction or supercompaction. Supercompaction for compactable waste used for previously compacted waste as well as for air filters. Incinerator ash. You can see here that when we use from incinerator, after that we need some compaction for its ash. Small metal species, soft plastics, thermal insulation materials. It has high volume reduction factor, VRF for uncompacted waste force, and its weight is about 1,200 to 2,000 tons. And let's pay attention to the liquid radioactive waste treatment methods. Surely, I'm sure that you have understood up to now that the waste must ultimately be disposed in a controlled. I concentrate to this word, in a controlled and reduced volume manner. So the radioactive components of the liquid waste must be captured, must be trapped by these processes: precipitation, ion exchange process, evaporation, reverse osmosis, ultrafiltration, microfiltration, and solvent extraction. And in the final stages of processing, we need to condition the waste packages. It's been divided. Conditioning has been divided to the three main elements: immobilization, packaging, and overpack. In the final stages of processing, the waste package must now find the optimal conditions for storage or disposal. So these processes are performed on it. Okay, let's have some definitions about these terms. Conditioning means include the conversion of the waste to a solid, I mentioned before, solid waste form, enclosure of the waste in containers, and if necessary, provision of an overpack. I will show you in the next slide a visual imagination about that. Immobilization means conversion of waste into a waste form by solidification, embedding, or encapsulation. This process reduces the potential for migration or dispersion of radionuclides during handling. This is the main risk of radioactive waste management. We have to prevent the radionuclides to migrate, to disperse in the environment, to have some risks for the persons and for the environment during handling, transport, storage, and or disposal. Demobilization and is an appropriate includes an appropriate matrix, for example, cement, polymer, or bitumen-based materials, or a combination of them. Low-level waste placed into a drum or other appropriate container, and the resulting containerized low-level waste forms the waste package. And packaging means preparation of radioactive waste for safe handling, transport, storage, and or disposal by means of enclosing it in a suitable containers. And the last one is overpack. Maybe we need to do that. A secondary or additional other container for one or more waste packages used for handling, transport, storage, or disposal. I tried to demonstrate some pictures in this slide, and this slide has been prepared to better understand what the output of the processing stage is, and actually what is finally to be stored or disposed. If you pay attention to the waste form, something that has been solidified in a cement matrix or bitumen matrix, and the outer shield of it is a container, and the combination of waste form and container is waste package, something that we have in our hand for managing at the final stage of radioactive waste management. And this is another publication of the IAEA. You can refer to that. And this is the final waste packages. This is an illustrative picture. The final waste package for storage and further processing in France. This is the waste package, and this is the crane they are using. And this is for our country. This is a basket involving 6 waste packages, 6 barrels utilized for transportation from generator from nuclear power plant, especially here in Bushehr nuclear power plant, to disposal facility, Anorak disposal facility in Iran. Let's come back to our roadmap. Okay, we are here. Storage. We passed processing, and this is the place and space where WP or waste packages are stored for various reasons. For example, such as for decay in radionuclides, in radioactivity, or disposal, space, for example, I don't know, limitations. Whenever you wanna deliver, you wanna transport or deliver the waste packages from the interim storage to the waste package to the disposal area. Maybe you don't have enough space in disposal area, and you have to store them. And this is another nice photo for storage of radioactive waste barrels. Okay. Let's have a definition for storage in the glossary, in the IAEA glossary. The holding of radioactive sources, radioactive material, spent fuel, or radioactive waste in a facility that provides for their containment with intention of retrieval. This retrieval is important word in radioactive waste management. And this is another publication, safety standards, IAEA safety standards, WSG 6.1 safety guide. Come back to the roadmap. Okay, this is the transport. After storage, transfer, we can refer to the movement of waste packages from generator to the radioactive waste operator site. It can even refer to inside any radioactive waste generator site. Okay. Transport in glossary includes the deliberate physical movement of radioactive material other than that forming part of the means of propulsion from one place to another. Imagine that, let's have a picture. Imagine that the radioactive waste is to be transported between two sites, generator site and radioactive waste operator, and inside these two sites, personnel or colleagues are trained in dealing with radioactive waste. But whenever we are transferring the radioactive waste packages during transport between the two sites, on the road or paths, transportation requirements and analysis of possible consequences are among the things that must be considered and observed. This is very important and essential in this subject. And this is another IAEA safety standards about the regulation for safe transport of radioactive material. And these are transfer vehicle used in Iran for consignment of radioactive waste packages from Bushehr nuclear power plant and another generators to Anarek repository, or used for this vehicle can be used for transferring inside the site, our site, from one building to another building for further processing. And the roadmap, we reach to the end of the life cycle of the radioactive waste package. We reach to the disposal stage. Okay, definition. Emplacement of waste in appropriate facility without the intention of retrieval. We had the word of retrieval in the previous slides. And this is the only stage mentioned in the design criteria of waste packages or design criteria for the repositories that doesn't require retrieval. We are not permitted to pick them up after disposal. And in this nice and lovely picture, the excavation process can be seen in Iran for near surface disposal trenches. This is so lovely. And this is for South American walputs, South American, South Africa site, near surface disposal site. Okay. Something that is important to be noted it should be noted that the trenches, this kind of trenches, will be covered by multi-layer caps after emplacement of the waste packages inside the trenches. And these two terms I wanted to mention here because these two terms are so important in our field. Closure means administrative and technical actions directed at a repository at the end of its operating lifetime. After the closing the repository, the closure phase will be started. And another word is safety case. Safety case. It was safety assessment document in the past, but the safety case recently refers to a collection of arguments and evidence in support of the safety of a facility or activity. This important document has to be prepared by the operator, by the manager of the operator for presenting to the regulatory body to demonstrate the safety of their facility or activity. And I want to add that these two publications are among the best in the field of radioactive waste management, actually one of the best. Okay, in this slide and in this image, I wanna refer you to this remarkable and memorable relationship between the level of radioactivity and the depth of disposal. If we have very low level waste, we can work in the ground level, and in low level waste, we can go a little bit deeper in the ground. And if the radioactivity increase, we have to go deeper for final solution of radioactive waste. And this is another safety standards, disposal of radioactive waste. And therefore, based on the figure in the previous slide, disposal types can be divided as follows: landfill, near surface, intermediate depth, and geological disposal and boreholes. And the last but not the least, once again, we briefly review the mental image I wanted to transfer to the dear audiences. The mental image created during this presentation of radioactive waste management based on this figure. You can see radioactive waste management at the top of this figure can be divided to pre-disposal and disposal, waste generation. After waste generation, you go through this box, any or all of the operations prior to waste treatment, such as collection. I explained about them. This figure is a little bit different in demonstrating the concepts and basics of radioactive waste. Collection, characterization, segregation, adjustment, decontamination. We have two paths for radioactive waste and then for cleared waste. And this is for candidate for clearance. They should be stored. They should be stored for decay, and then we can put them in we can release them to the environment or landfill, depending on the physical form of the waste. And this path you can see something unexplained in this presentation. You can see the various stages of radioactive waste management here: pre-treatment, treatment, conditioning, interim storage, transport, and the last, disposal. And this is the references I have used. And thank you so much for your paying attention.
Thank you, Dr. Azwani Nejad, for your informative presentation about different parts of radioactive waste disposal and radioactive waste management. Let's go to the next presentation, and after this, we will have a question and answer sessions.
Okay, okay, thank
So,
you. Thank you.
thank you so much.
You're
So, I would
welcome.
like to invite
I will stay
Dr.
here. I will stay here. Yeah.
Yeah, thank you so much. Next presentation, Dr. Burumandi, the floor is yours. Thank you.
Thank you. Thank you, Dr. Kosuzos, for your introduction. Hello, everyone. It's great to have you all here. I'm Mehdi, and I'm going to discuss about site selection of disposal facilities. Please bear with me to share our presentation. Could
Good.
you see?
Yes, good.
Oh, okay. So, hello again. I'm going to talk about site selection for radioactive waste disposal facility. As Reza mentioned, disposal is the final solution for radioactive waste management. So this part needs more attention to operators to have a adequate isolation of waste to the environment. Here is a quick snapshot of the contents that we are going to walk through step by step. Firstly, we define the problem. After that, I will explain about objective and approaches of site selection. There are different stages for siting of disposal facilities. The main criteria should be considered in waste disposal facilities will be explained. Some tools and method could be used, will explain, and I will give you some samples from our actual work that we had it in our country for site selection. Actually, I'm going to present general topics of site selection, but I thought some samples could better understanding from these processes for audience. Let's start with a history of a disposal facility. This picture shows Sheffield disposal facility in the US. The Sheffield low-level radioactive waste disposal facility opened in 1968. At the beginning, the site geology site investigation shows that the geology of site consists of sand, some sandy layers, our lake deposits of silt, and the climate is humid with mean annual precipitation was about 89 centimeters. That's very high. It's 4 times of our average precipitation in our country. This site was used for disposal until 1978, after 10 years from operating the site. Up to that time, there are about 90,000 cubic meter of waste disposed there. but unfortunately in 1977 they detected tritium in some wells some wells were used for monitoring in the sites. So they have to uh, more investigation, and this follow-up investigations showed that this sandy layer have more permeability than expected, which than expected in first site investigation. These sand layers which allow leachate to migrate to the environment, and this failure uh, this failure uh, have to USNRC decided to close this facility and stop disposal in this site. After 4 years, in 1981, also they detected tritium in off-site wells of the disposal facility. So they completely closed this facility, and currently they have to monitor around the site, and this monitoring will continue until 23A. So I want to just show that importance of site investigation and site selection of disposal facility in waste management system. Fortunately, nowadays we have many standards from agency. Reza explained well about the structure of these standards, and I bring some standards of this related to the disposal. You can see them, some of them related to classification, and some of them will be used for catching different criteria for designing, and the requirements should be considered in disposal facilities. The development of most type of disposal facilities is likely to take place over extended periods of time. The period over which disposal facilities will be open prior to closure will extend it for decades. Usually there are three main phases in development of disposal facilities: pre-operational period, operational period, and post-closure period. Usually siting, always siting is the process of selecting suitable site, and it's a start as soon as decision makers decided to take investigation for potential region or sites for disposal to host the repository. And meanwhile, regulators should issue some license for different stages of disposal development. For example, siting license, construction license, operational license, and post-closure license. And the siting terminates when regulatory body or any other authorized organization accept the suitability of the site. So the siting is start when you decide to search for a site for disposal, and when regulator issue the license, the siting process is finished. You can see this diagram shows the different stages of disposal, site selection of disposal facility. So the main question is, what is the main goal of site selection for radioactive waste disposal facilities? Currently, you know, the objective of radioactive waste disposal is to isolate waste. How waste it doesn't result in any excessive radiation exposure to human and environment. Here, I want to explain more about the two concepts. One of them is containment, and the other one is isolation. The containment of radionuclides is the waste in the waste form and packaging over a defined period has to ensure that the majority of shorter-lived radionuclides decay in situ. To containment of radioactive waste implies designing the disposal facility to avoid or minimize the release of radionuclides. Containment may be provided by the characteristic of the waste form and packaging, and by combining this characteristic to other engineering barriers, component, and design of a disposal system, and the geological characteristic of the host. But isolations used to prevent and minimize the migration of radionuclides to the environment. So isolation means design to keep the waste and its associated hazard apart from the accessible biosphere. Usually, for near-surface facilities, isolation has to provide by the location of the design of the disposal facility and by operational and institutional control. But for geological and or for deep geological repositories of radioactive waste, isolation is provided primarily by the host geological condition as a consequence of the depth of disposal facility. So I wanted to answer the main question, the basic objective of radioactive waste disposal. The basic objective of the siting process is to select a suitable site for disposal and how to demonstrate that this site has characteristics which when you combine with the facility design and waste package provide adequate isolation of radionuclide from the biosphere for desired period of time. So now I want to mention that basic objective of siting is to focus on isolation of radionuclides in disposal facilities. There are many approaches for site selection, but two main approaches is site screening that which start from a national map and or a national boundary, and the other one is preferred site or a list of sites with a prior favorable characteristics. The first one or site screening approach, you should start with a national map or any other administrative unit, could be a national boundary or for example, it would be a state or a province. It starts by this one, and by then focusing in this area, you can find some search area for more investigation. After that, you select some site in this research area, and finally, you focus on the selected site, and by more investigation on that, you select the best suitable disposal facility. In the preferred approach site, one or a short list of sites with a prior favorable characteristics exist. Maybe if site selection team will be lucky, there are some volunteer in their country. They would be volunteer to investigate their disposal facility in their state. It could be land ownership or the presence of existing nuclear facility, which is potentially strengthened by the proximity to a storage of a major part of the national waste inventory. Or maybe you have some sites before that previously investigated well, and you can take advantages of them. But don't forget to pay attention this important part of detailed site investigation. This approach just skip from first stage to the final stage, and for example, from conceptual planning stage to the detailed site characterization. But in systematic approach, you can follow the step-by-step step-by-step investigation of different sites. NIMBY, maybe you heard about this influence. This is a powerful influence of local parties in all around the world. There are some local communities that they have objection from disposal facility or any other energy infrastructures. Actually, NIMBY defined as local opposition can be an obstacle for developers of energy infrastructures. This objection may arise from some concern about environment, about visual appearance, or some noises, and there is a powerful influence that should be considered in site selection process. So you have to accept disposal facility by public, and you have a good communication with public to demonstrate them safety and environmentally safely of disposal facilities to the public. Because we are going to show different stages of site selection, I bring here the four main stages of site selection that presented by agency and many countries which use this strategy for site selection. It includes four main stages: area survey stage. The first one is conceptual and planning. After that, area survey stage, site investigation, and finally, detailed site characterization stage. This is used for different type of disposal facilities around the world. But don't forget that site investigation may be continue all over development of a disposal facility, because you want to show to the regulator or the public the correct performance of disposal facility, and you have to monitor continuously your disposal facility and the environment and show performance of right performance of your disposal to the public. Here, this is another diagram that shows this strategy for siting of disposal facility. Again, if I emphasize these stages, the first one is conceptual, area survey, site investigation, and detailed site characterization. At the first stage, in the conceptual planning stage, you provide an overall plan or a strategic plan for your site selection. In this stage, you provide some overall plan about cost, about human resource, about main criteria, and other parameters should be considered in the whole process. I bring the main tasks should be considered in waste disposal in this stage. They include waste inventory, conceptual design, and siting criteria. In this stage, you have to know about the type of waste to be disposed. You have an estimation about the projected waste volume and also about the radionuclide contents. You may establish a waste acceptance criteria, and the main part is defining and establishing the screening criteria. It should be used in different stages of area survey and site investigation. Should be considered more. And also generic safety assessment can be provided during this conceptual planning stage. You saw that this figure in Mr. Razwanjad's slides. This shows the different type of disposal facility. So in conceptual planning stage, you should know which type of disposal facility you're looking for. Actually, it depends on your understanding and from your inventory, and about the volume, radionuclide content, and level of radioactivity of waste should be disposed. So this type of disposal facility, near surface disposal facilities, borehole, DGR or deep geological repositories. So at this stage, you select two type of disposal facilities. If you have a national plan or a national policy about your waste management system, you can refer to that and select the disposal type. For example, in our situation, we selected near surface disposal facility according to our waste inventory and also our conditions in the country. And also you provide a strategic plan about the time, cost, and other parameters should be considered in future stages of disposal facility. From this slide, I will focus some criteria should be considered in disposal facilities. This is one of the most important parameters should be considered in in site selection of disposal facilities. And this criteria should be developed in accordance with national regulatory requirement and also take into account wider stakeholder and interested parties and other needs of the requirements. There are two different type of criteria. One of them is exclusionary criteria, and the other one is preferential criteria or suitability criteria might be developed during conceptual and planning phase and of the siting. And the choice of criteria is generally based on undertaken by in open and transparent manner and depend on national context and particular circumstances of disposal program you should have in your country. I bring some main criteria should be considered in site selection. There are different methods for classification of criteria, but for example, you can classify based on technical, environmental, and economical conditions. But according to our situation, I categorized in three main classes. Some of them categorized in containment and isolation of category. The other one is long-term stability of the disposal facility, and The other one is socioeconomic criteria. In this one, we consider geology, hydrogeology, and geochemistry of the areas and sites in long-term stability, tectonic and seismicity, and surface processes, and meteorology. And for DGR, climate change should be considered. For socioeconomic category, we consider transportation, land use, population distribution. You have to consider environmental protected area, and other man-induced events should be affect your stability of disposal facility. From this slide, I will give you some more information about the criteria, but I won't go more detail, but generally I will explain what parameters should be considered. From geology point of view, the geological setting of the site should contribute to the isolation of waste, and it should be characteristic to limit the release of radionuclide to the biosphere. Please pay attention to this subject in different stages of site selection. You have considered criteria in different details. For example, in area survey stage, you have a study some national geological map, but when you go more further, you have to consider detailed lithological subsurface characteristic and other. So in this slide, I just bring some important parameters should be considered for each criteria. In this slide, you can see the structure, different structure of geology. You can see, for example, syncline or anticline have a different behavior to the waste disposal, and also the permeability of different layer should be considered precisely in selection of the disposal facility. The most suitable geological formation for disposal facility includes rock with extremely low permeability to prevent from percolation of water. There are three types of rocks around the world, include of crystalline rocks, salt domes, and argillaceous information such as claystone and siltstone could be used for disposal facility. Usually, if you study about the geology of different disposal facility around the world, you can see mainly different country focuses on this type of lithology. And also deep underground water system which have little influence on surface water for periods of hundreds or thousands of years, where we are facing with near surface disposal facility. We talking about hundreds of years, and when we're dealing with deep geological repositories, we have to consider criteria for thousands of years, and this is very important parameters that should be considered for being safe of disposal. The other parameters is hydrogeology and geochemistry. In hydrogeology point of view, the hydrogeological setting of the site should include low groundwater flow and line flow paths in order to restrict the transport of radionuclides. In area survey stages, maybe you not enough information about the hydrological condition of the site, but in site investigation stages, you have to know about the location and extent of groundwater system, about the flow rate and permeability of different layers of the site, and also about about the regional and local water table in the environment of disposal facility. The other parameter is geochemistry of groundwater, and also geochemistry of the geological host should contribute to limitation the release of radionuclide. I mentioned about the isolation, so this is one of important parameters should be considered for isolation of radionuclides in the disposal site. And also, geochemistry condition should not significantly reduce the longevity of engineering barriers and durability of engineering barriers. For example, there are different effects of geochemistry, include corrosion of engineering barriers should be considered, solubility and sorption of different radionuclides in the environment, and maybe in DGR, potential for gas generation should be considered. Then another important parameter is tectonic and seismicity. It is clear for all that sites should be located in an area with a low tectonic and seismicity. So the isolation capability of disposal system will be remain safe if you select a site in a calm area. In first stages of site selection, for example, in area survey, when you considering national map, maybe you just focus on seismic hazard zonation. Usually there are some maps for each country, but when you go further and you reach to the final stages of site selection, you have to consider seismic hazard analysis. It should be used by deterministic or probabilistic methods to know about the seismicity hazard of the site. The other parameters is surface process. Surface processes such as flooding, geohazards such as landsliding and erosion should not occur, which such a frequency or intensity could affect the ability of the disposal facility. Also, topography and the location of surface water bodies should be considered in this criteria. The other criteria is meteorology. The site area meteorology should not be characterized such that effect of unexpected extreme meteorological condition can adequately considered in design and licensing of disposal facility. For example, you can consider precipitation, wind direction, prevailing wind direction, and speed for dispersion condition of maybe there are some potential for atmosphere release, and you have to consider these parameters. About man-induced events, I want to explain that sites should not be located in areas where the containment and isolation function of the repository are likely to be disrupted by future human activities. This is known as human intrusion activities. So, in screening of potential site should be considered that in future we decrease the probability of human intrusion activities. So, in the screening of potential sites should include consideration of the distance from facilities and associated impacts such as mm, oil refineries, chemical plants, airports, and also important air corridors should be considered in this criteria. The other one is transportation of waste. So the site shall be located such that the access route will allow transportation of waste with a minimum risk to the public. And also, if you want to consider cost and risk of the transportation, you should consider the distance between generator of waste and uh, waste disposal facility. So these parameters should be considered in two ways. One of them is about the cost, and the other one is safety. But mainly, you have to consider safety more than cost regarding to radionuclides. And the other parameter is land use. You have to know about the future land use of environment and the sites around the disposal facilities. And you have to consider future uses of the land in the vicinity of the proposed area. So usually there are some land use map in different countries, and you can use such as these maps for area survey stage. Population distribution. It is again clear that consideration should be given to avoidance from high populated area to decrease the potential hazard for the public. And the another parameter should be considered is protection of the environment. Actually, there are some protected areas such as national park, historical monuments, or archaeological findings should be considered in area survey stage. There are some surface water and groundwater resources should be used by the public, and the wildlife and existing terrestrial and aquatic vegetation of the environment should be considered in the protection of the environment. So I explained about the criteria should be considered in future stages of site selection. The second stages of site selection is area survey. The objective of this stage is to identify one or more potential sites. These stages itself include of two phases. The first one is regional mapping, and in this phase we identify some areas with potentially suitable sites, and in screening stage we select some potential sites from selected sites from previous one. You can see some national maps used for in this stage. This is the seismic risk zonation of Iran and also population distribution. Also, I want to mention that in area survey stage, usually we focus on desk-based studies, and we usually uses reports, maps, and investigations have exist in every country and provided by different organizations. Here I want to introduce some tools and methods to be used for consolidation and for consolidation of different layers. When you I want to mention that the site selection is a multi-criteria decision analysis or multi-criteria decision-making system. So you have many criteria, and maybe you have some different alternatives. So you deal with multi-criteria analysis. So it's better to use some tools and methods uh, to handle adequately of these parameters. One of them is AHP, analytical hierarchy processes, known as AHP, and the other one is simple additive weighting method. And also you can use some fuzzy logic to provide different maps for synthesis of different layer for overlaying of different layer, because you want to give a weight for each layer, and it's better to define this weight by using experts. So AHP could present an accurate approach to quantifying the weight of decision criteria. Uh, this is an example of synthesis of different layers should be considered. For example, in this method, we use simple additive weighting method, and in another AHP used for synthesis of different layer. And finally, some areas excluded and some area remains for further investigation. You can see overlaying of different layer from our country that create this map. In this map, this is performed in first stages of area survey stage, known as regional mapping. So in this stage, we selected 3 areas, and after that, we selected 9 potential sites for further investigation. This is a screening phase. In a screening phase, you consider the mentioned criteria and using by weighting methods such as AHP and SAW, and you can provide and you can comparison between different sites uh, by their importance. So you can provide some tables for to have a comparison between different sites. And finally, by comparison between these sites, we select 2 sites to have more investigation. For that, the Gudarberenji and Anorex sites was selected for disposal facility in our actual work. The third stage of site selection of disposal facility is site investigation stage. The site investigation stage involved a detailed study of one or more several potential sites which identified in the area survey, and you have to investigate them to whether they are acceptable in various respects, and particular in safety point of view. In this stage, you gather some information that develop a preliminary site-specific design, and also you have some information could be used for preliminary safety assessment of the selected sites. This is a generalized approach for site investigation of disposal sites. I don't want to go more detail about the how to study different parameters of the disposal site, but I just show main studies should be considered in site investigation methods. There are some desk studies. There are some non-invasive methods such as field survey, using some satellite images, and also some geophysical method could be used for non-invasive methods to obtain data for investigation of the site. And also in this stage, you may have some boreholes to have details about the subsurface condition of the sites, and also some test pits or trenches to get more data about the conditions of groundwater system and geologic condition of the sites. You provide some data and data will be processed, and some reports should be considered. And at this stage, you reach a general understanding of the site, and this could be provided by creating some models or maps which be used by safety assessment report, by environmental impact assessment, and also this data could be used for repository design. Maybe finally in when using the data for these main categories of reports, you may find that there are some gaps, so you have to follow up more investigation again to reach a good understanding from your site. For example, in our situation, we consider a geological map of different sites. The previous one is about geology. This one is comparison between geophysical condition of the site and up to some depths which is required, and also there are some geotechnical studies show the subsurface layer of disposal facility. You can clearly clearly see the difference between type of lithology in these sites. So by comparison of these parameters, you can select the best suitable site for final stages. In final stage, known as detailed site characterization, or previously known as site confirmation stage, you have to support and confirm your site selection. You have to show your regulator that the site will be safe for 100 or 1,000 of years, and the purpose of this stage is to conduct detailed site investigations. And also you have to provide additional site-specific information which be required by safety, environmental impact assessment, and licensing procedures. And for DGRs, maybe you have to provide a site-specific URL, underground research laboratory. Around the world, currently there are a lot of DGR sites that may establish an URL, and they are measuring different parameters of the formation, and they want to show the suitability and stability of the geological formation. And also may you have provide for understanding the 3D models to provide a good understanding from the geology of the site. If I want to refer to a standard of agency, I can refer to the SSR5 that mentioned that the site for a disposal facility shall be characterized at a level of detail sufficient to support a general understanding of both the characteristics of the site and how the site will evolve over time. So you have to understanding from the evolution of the site in the future, because disposal facility may be safe for thousands of years for zoological and hundreds of years for disposal facility. Finally, the parameters which gathered in different stages of site selections. You have some information about site characteristics, you know about the waste inventory, and also you have some requirements and assumptions from regulatory. So by combination of different data, you have create data for design activity, and after that you have detailed information to design a disposal facility. And this is a synthetic image of rock volume at Sellafield of UK that provided in site characterization stages and show that they reach a good understanding from their site about the small fluctuation in different parameters of the host rock. To summarize our process we did and I explained in these slides, I bring here the flowchart of our site selections. You can see we start with conceptual and planning stage. We selected near surface disposal as our method, and after that in 3 periods we selected some areas first, and after that 9 potential sites, and finally we select 2 sites for more investigation, and after that we go through site characterization, and by characterizing these sites we select anaerobic waste disposal facility as a final repository of our sites. So I thank you for your attention, and I hope it could be informative and engaging for you. Thank you.
Thank you, Dr. Burumandi, for your very informative presentation that covered all our aspects of technical aspects of the waste site selection for waste disposal. Thank you. So we have time to question and answer. Dear audience, if you have any question or comment, you can use raise your hand, and also you can use the chat box, write your questions.
Your voice is unclear, Dr. Pasazas. Voice is unclear.
No? Okay, it is good.
No,
Yeah.
now it's okay.
That's
Okay. Dear audience, if you have any questions, you can raise your hand and also use chat box for to write your question there. Yes, Mr. Yasir Murtaz. Dear Maru, can you turn on his microphone?
Yes, I did.
Thank you.
Mr. Yasser, who is yours?
And then after this, Syrian team. Mr. Yasir, can you hear us? I'm not sure that His microphone is.
I changed his responsibilities, so
Hello?
I can
Yeah,
hear
yeah.
you.
Yes.
Yeah, can you hear me, sir?
Yes,
We can
please.
hear you.
Okay, sir. I just want to ask that is there any example that shows the planning we are making for the disposal of waste? You know, can we did we feel in the past that is it's required some more improvements in the planning?
Planning
Or
for what?
I can change my question that there was there any kind of accident that shows there was a lack of planning for disposal of the waste?
Like this will. Yeah, thank you for your question. Actually, there are some examples, but it returns many years ago. There are the one it known as Maxi Flat site in the US. Actually, it has a failure and it's polluted the environment, and regulator have to close this site. And also, I mentioned about the Sheffield site in the first slide of my presentation that this I know these two sites, but I know there are more than and maybe you can find it on the web.
Okay, sir. Okay, thank you.
Well,
Thank you. Thank you. And then Syrian team, can you model to give him access to
Yes, I
ask his
did.
question?
Yeah,
Yeah,
I changed the responsibilities.
thank you.
Another question?
Syrian team, I see hands up.
No, we can hear Syrian team. We,
पूछ ना पूछ कंट्रोल शिफ्ट के दबाना
They make you can use chat box if you have any problem with your microphone.
I mean, the Syrian team, the microphone is still muted.
Okay, may I ask a question before the problem solved? My question is about, you mentioned about some high level and low level different classification of waste material. Which kind of radiation they have? For example, gamma radiation, neutron gamma radiation, alpha. Which kind, is there any classification for different types of radiation, or just focus on activity?
okay, let me show you my presentation. I pointed. Let me show you. بس هست. اینجا. Let me answer you on the presentation. Dr. Kassil says,
Thank you.
you're welcome. Can you see my presentation or not?
No.
Not now.
Yeah, yes, it's coming. Yes, yes, it is okay.
Yeah. Okay. Could you please pay attention to this figure? This is the amount and the numbers. This is 10 powered 8, 10 10 order 9 becquerel per gram. This is the threshold for for the activity content of the waste Becker program. This is a total activity, okay, and this is 400 Becker program just for alpha. And this is something you can imagine the order of magnitude of the numbers here. I would add these kind of numbers to the figures of IAEA publication. There isn't this number there, but I added these numbers from somewhere that they were mentioning about this disused sealed radioactive sources. Got it?
Okay,
Yeah.
thank you.
You're welcome,
Thank
sir.
you. Okay. Guillermo, is the Syrian team problem solved or? Syrian team, can you hear us? Okay, maybe you can use the chat box or send us an email to related to your questions. Okay, thank you. Thank you, Dr.
Sorry, Dr. Yassel. I
Yeah,
changed the Syrian teams and responsibilities right now again. So do you
yeah.
hear me, Syrian teams? So you can like now. Okay. I can see you. I can see you.
Finally,
Yeah, we
Finally.
can
yes.
see your
So
camera,
it
yes.
was, yeah, it was from your side. Can you hear me, please, now?
Yes, I gave you the full responsibility on this
Oh
web
yeah,
for a
Okay.
moment.
we
Thank
can
you.
see you.
No problem. It's solved now. Okay. First, I would like to thank both the presenter, Mr. Riza, and Mihadi for the Mehdi for the fruitful presentations, and for the IEA, of course, Scientific Secretary for this initiative to have such a webinar on radioactive waste. However, first, I have one question. When you mentioned to Riza, of course, Mr. Riza, you mentioned storage that we don't have. We can storage as in definition. It can be with interval intrusion, retrieval. Okay.
Yep.
But since we are, I think there is two definitions. There is the for the interim storage and for the final storage. Final storage, there is no intention of retrieval. It's just storage for disposal.
Yeah, you're right.
Yes, and that's what confused me in your presentation. And then when you said that the waste acceptance criteria it has to be developed by the operator or the regulator, and then you mentioned that it has to be approved by the regulator. So I believe in most cases it has to be developed by the operator because he's the one responsible for all the experimental and the details for pre-disposal. So it cannot be generated by the operator, the regulator and approved by himself.
Yeah. Let me explain more about the VAC.
This is confusing, either from the IEA side or from your side. It's good. Yeah.
Yeah, let me explain a little bit about the waste acceptance criteria document. In our country, whenever we wanted to develop the waste acceptance criteria, we created a work group, and the members were from regulatory body, the generators, our holding company, the operator of the waste management company, and after developing a draft, we shared it to all members to give some comments on it, and complete the document. And then after revising the document, we sent the document to the regulatory body, and then after some reciprocating collecting comments, it has been approved by the regulatory body. But yeah, this is the procedure we did it for VAC developing.
Okay, that's good. Yeah,
Yeah.
that's very logic and comprehensive. Yeah. And for Mr. Mehdi, you mentioned that the example in Sheffield, you started your presentation with Sheffield disposal site. I think it was in 1987, something like that, in the USA. And you mentioned that there was a leakage discovered later on in the site with the tritium. Then you have discussed all the parameters you went in the presentation. So could I say that siting is not only the reason behind any leakage which will happen? I think it's the siting and the design. And maybe, of course, because this will take a long process. It will take like 20 years, if we say, from the day of planning. So many things will be developed technologically worldwide within these 20 years. So maybe then modification in the waste acceptance criteria should be taken into account. So it's the waste, I believe, the siting, and the design as well. Especially the environmental condition is changing all over the world.
Yeah, exactly. You're right.
Yeah.
This is not because of just the siting and site investigation. Actually, the safety of a disposal facility is as a result of site design and also waste form and waste packages conditions. So the combination of different parameters should affect on safety of disposal facility. But I just want to show the importance of selecting a suitable site. Whenever if you select a suitable site, if you have any failure or problem in design or waste packages, it should be retain or limit the release of radionuclides. So maybe if they select, for example, on a arid area or on a geology with low permeability, maybe the release could be lower than they observed.
Okay, can you share with us your experience if you want to select the site? Would it be near the operator or the storage or nearby the generator? Because this is really a main issue for us.
In our country, the selection of disposal facility is responsibility of operator, because
not the responsibility, sorry, I mean the location, the siting. Will you choose it nearby the operator? I mean the storage and the radioactive waste management facility, or would it be nearby the waste generator?
As I know, in many countries.
Sorry, but just sometimes it will be like the disposal could be in the north, the countries or most of the facilities that the generator will be in the south. So this is a big issue, the transportation issue as well.
Yeah.
So that's the reason I'm asking.
Yeah, sorry to interrupt. There is a 1,000 kilometer distance in our country between generator site, Bushehr nuclear power plant, and Anorak site repository. Got it? There is a line distance. There's a line distance between these two, and yeah, you're right. Maybe there will be some issues about the transportation. And but as mentioned, described in his presentation, there are some criteria for selecting the site. and this distance was one of the criterion, you know.
Okay.
And sorry, I want to add something. And if you remember, there is a approach known as preferred site. Maybe in there are in some countries some volunteer to select their disposal in their administrative unit, but usually it's better to select a site in a systematic approach because, in my opinion, the safety of a disposal facility is very much more important than
The others.
the others.
Okay.
Okay, thank you.
Thank
And
you.
Thank you.
final comments, I would like to request from the IEA Scientific Secretary if we could have a similar webinar in the future regarding radioactive waste management, but to be more in depth for like country sharing experience, it will be really nice.
Thank you.
Thank you.
Thank you.
Thank you.
Okay. Thank you, audience, and thank you all for your almost we could share the information about
Excuse me.
the next
Can you hear me?
webinar. Yes, yes.
Sorry, there's some noises. Uh, I hope you
Yes, sir. Yes, sir. The voice is unclear.
Because, yeah, this is okay
okay.
now. Yeah.
Yeah, this
Challenging.
is better.
Yeah.
Oh,
Yes, yes.
Yeah, nice
yeah.
to see you online. This is Xiaojing Guo from Tsinghua University, China. I am also a steering committee member of ANENT. So first, I want to show my sincere thanks for your presentation today. Very, very detailed and very comprehensive presentation about radioactive waste management. And the second,
Thank you.
I have a small question about your presentation. Um, in the first presentation, you showed about the containers containing the radioactive wastes and you buried them underground.
Yeah.
And I wonder if there is any liquid waste in the containers. How, yeah, do you process the liquid? Because you
Yeah.
cut up one container, we can see the compressed materials inside. Uh, so I wonder if there's any liquid waste
Yeah.
you process.
Let me explain. Yeah. I mentioned in my presentation that there is a document called waste acceptance criteria. This is something so essential and important document that approved by the regulatory body. You can imagine that it's a border. It's a border between the generator site and the waste management site. If there is any liquid inside the barrels, inside the waste packages, it shall not be consigned or transported to the operator site. Got it? And this is one of the criteria mentioned in the waste acceptance criteria. And if there is some liquid inside the barrel, inside the waste package, before disposal, it it shall be treated by, I don't know, but some kind of treatment process. For example, in our country, we have a line for liquid radioactive process, and okay, I hope that I can answer to your question. This is the limitation and restriction we have in our country. Uh, mentioned and developed in the waste acceptance criteria.
Thank you. Thank you very
You're
much.
wel-
Because
you're wel-
I think this is a little different from the process of radioactive water from the reactor, right? We are talking about waste, not the
Oh,
radioactive material.
okay, something I'd like to add. In our country, there is a treatment process, treatment line in the Bushehr nuclear power plant. Maybe there are some streams, including liquid, but in their own site, it should be dried and treated before transferring to the
Yes.
repository site. Got it?
Yes.
Yeah.
Okay. Thank you for your.
You're welcome. You're welcome, madam.
Thank you.
You're welcome.
Thank you so much. Before the closing, I would like to invite all of our audience for the next webinar, which is the information is presented in the chat box. It will be about the International Nuclear Science Olympiad that initiated by the agency for the second Olympiad that be held in the next year, 2025. Okay, dear Marina, do you hear? Okay, may I I can close the close the this webinar. Thank you all. Thank you,
Thank you.
dear presenter, from your informative information and deep presentation about the radioactive waste management system. Thank
You're
you
so
all.
welcome. You're so welcome.
Thank
Thank
you.
you so
Bye.
much.
Thank
Thank
you.
you.
Thank you. Bye.
Thank you.
Bye-bye.
Thank you. Thank
Thank
you.
you all.
Thank you.
Thank you
Thank
so
Thank
much.
you.
Thank you. Bye bye.
Bye-bye.
Bye bye.